welcome to your first day of notes for PR AP Physics. Please have out a notebook and follow along as I go through some of the basic intro to physics stuff and math concepts that you are going to need this year, and that will help you complete your first homework assignment. So starting with chapter 1 of your book, it's just the intro to physics, and section 1.1 is basically defining physics, and I would say you can define physics as the study of the fundamental laws of nature and laws that underlie all physical phenomena in the universe. So this is what we're going to be doing this year, studying the fundamental laws of nature and the laws that underlie all physical phenomena in the universe. And a lot of times these laws that we're talking about are expressed in terms of math. So next section in your book is 1.2, and it defines the idea of SI units, which are the standard units that we are going to be using in order to compare quantities. So the first thing is we are going to focus a lot on distance. And you need to know that distance is going to be measured in meters, which is lowercase m there. So we are not using feet and miles and stuff like that. We are always going to have to convert. And one conversion you may need a lot this year is the fact that 1 meter is 3.281 feet. The next SI unit that we are going to need is for mass. And instead of using like pounds or tons or something like that that we use in the US and you're maybe more familiar with, we are going to use kilograms, which is an abbreviation kg. And 1 kilogram, we'll do conversions in a little bit, is 1,000 grams, and it's about 2.2 pounds. So about the equivalent of like a half a gallon of milk or something like that. And finally, we are going to need the SI unit of time, which we are going to measure in seconds, which is abbreviated with a lowercase s. And you should know this, but since there are 60 seconds in a minute and 60 minutes an hour, there are 3,600 seconds in 1 hour. That will be definitely very useful this semester. The second section that we have is 1.4, and this is sig figs and scientific notation. And the first thing, sig figs, while they are important, they are not as stressed as they were in chemistry, just because we're not measuring minute amounts of things. I would just say for the AP test, do not go extremely overboard with rounding or leaving too many decimals. But if you round to 2 or 3 and store your answers in your calculator along the way, you should be very good to go. But you do need to know an example, I guess, for scientific notation would just be, let's remind ourselves how to do something. So let's say I've got 56,341 meters, and I want to put that in scientific notation. Well, I have to put the decimal point right here between the 5 and the 6, and so I can go ahead and count. The decimal point is originally right here, and I will go over 1, 2, 3, 4 places. And so my answer in scientific notation will be 5.6341 times 10 to the 4th. And don't forget to stick your unit on there, meters. Same kind of thing if we're going the other way. So if you have a really small number, such as 0.0086 kilograms, now that we're moving to the right, we're going to have a negative in our scientific notation. So we're going over 1, 2, 3. And so we will get 8.6 times 10 to the negative 3 kilograms. Oh, sorry, 8.6 times 10 to the negative 3 kilograms. Yes, that is correct there. The next section in your book is converting and factor labeling, which you are going to have to do almost every day. So I will title this converting. And let's just go through a few examples. That'll be the easiest way to do it. So what if I want to take 6.3 6.3 meters and put it into inches. How many inches are in 6.3 meters? You're always going to start with what we know, so 6.3 meters, and then you're going to do what I call factor label. You could hear like the goalpost method, but the idea is to cancel out the units. So since I have meters in my numerator here, I'm going to want meters in my denominator, and I'm basically multiplying by the number 1, something divided by something. So I'm not changing this standard 6.3 at all. So what I can do is I know that 1 meter is 3.281 feet, and you could look that up or just start knowing it. And so now meters cancel with meters. And if I stopped there and did 6.3 times 3.281, I would have my answer in feet and I would be good to go. But I need to do one more conversion to get it to inches. So now I'm going to say 1 foot, and I'll put that in my denominator so feet can cancel with feet, and that is equal to 12 inches. And so I get 248 inches as my answer. Now, one reminder that we may not have seen for a while, if we want to do the same kind of thing, but let's say I have 12 meters squared and I want to get it into inches squared. The one thing you have to remember, yes, 1 meter is still 3.281 feet, but now I've got this meters squared. So what you need to do, and I like to put parentheses on my bottom and my top there, is you can't forget you have to square everything in the top and everything in the bottom. So now meters squared will cancel with meters squared. And then next line, yes, 1 foot is 12 inches, but you have to put everything in parentheses, square that. And so in the end then, you'll take 12 times 3.281 squared times 12 squared, and you get 18,601 inches squared as your answer. The final type of conversion that we're going to have to do is one that's something like 65 miles per hour. Now my big suggestion for this one is make sure you put the per part in the denominator. That per word means divided by. So you have 65 miles per 1 hour. Now the reason I'm so specific about that is because that's going to dictate how I do the rest of the problem. So let's start with miles. I want to convert that to meters, let's say. I'm going to turn it into meters per second. So I'm going to put 1 mile in my denominator here, and 1 mile is the same as 1,609 meters. So now my miles have canceled with miles. If I stopped there and did 65 times 1609, notice my units right now would be in meters per hour. But I don't want that. I want meters per second, so you additionally have to do one more step, or I cancel out this hours. This is where a lot of people get stuck, but since the hours is in the the denominator down here, I need to put 1 hour in my numerator up here, so they cancel, and 1 hour is 3,600 seconds, and so then you multiply everything in your numerator, 65 times 1609, divide by that in your denominator, and you get 29 meters per second. The last few things that aren't specifically, I guess kind of section 1.8 in your book, is the idea of problem solving. While it's good to look over that section, I'm going to summarize by teaching you this thing I like to call the guess method, which is my way of kind of going through all the steps that you need to do when you're solving a problem. So G in my little acronym here stands for givens. U stands for unknowns. E stands for equations. S stands for substitute. And finally, the other S stands for solve. So this means anytime you are given a problem, you first need to look at your givens. What are they telling you in the problem? Then you need to look at your unknowns. What are you trying to find? Next step, pick an equation. You will have a ton of them to pick from, but you have to pick the right one. Finally, substitute in your givens and your unknowns into your equation. And then last but not least, go ahead and solve, and don't forget to put units on the answer. And then one final thing that you may need to remind yourself about is a little bit of trig. We will be doing a lot of that. So for instance, don't forget if I have a right triangle here with an angle, and I call this side A, B, and C, we have Pythagorean's theorem, which says that a squared plus b squared equals c squared. And then additionally, you will need to know your trig and the idea of SOHCAHTOA. If you've never heard that acronym before, S, or the SO part, stands for sine, and that is the opposite over your hypotenuse. So if I wanted to find the sine of what I labeled theta right now, my opposite side is B, and my hypotenuse is C. The co part stands for cosine, and the cosine of my angle is adjacent over hypotenuse. So my adjacent side is A, and my hypotenuse is C in this case. And then finally, the TOA stands for the tangent, and that would be opposite B over adjacent A. And then my last bit of reminder, for any of these trig functions, if you need to solve, I didn't put a theta in there, for the actual angle, what you need to do is take your inverse trig function. So for example, in this first one here, if you wanted to solve for theta, what you would do is you would say theta is equal to the inverse sine of B over C. And make sure your calculator is always in the correct mode. In this class, we will be in degree mode. So from here on out, that is about it, but what you need to do is please log on to the Google app that was given in your email list, and please complete the following questions. Thank you.